Hi, my name is Tariq and this is my project presentation for Genetic Algorithms course. The title of the project is Energy Conservation and Coverage Maximization in Wireless Sensor Networks Using Genetic Algorithms. Here is the table of contents. We will start with introduction. After that, we will discuss some optimization parameters and fitness function and weighting coefficients will be discussed after that. Then results and conclusion will be discussed in the end. In this work, our objective is to design wireless sensor network topologies in such a way that field coverage, connectivity, and network lifetime are optimized. We assume that our network contains three different types of nodes: the X nodes, the Y nodes, and the Z nodes. And there are also some out of range and inactive nodes. We have some constraints on these different types of nodes. For example, the number of X sensors is going to be smaller as compared to number of Y sensors, and the number of Y sensors is going to be smaller as compared to number of Z sensors. Moreover, the range of X sensors is going to be bigger as compared to the range of Y sensors, and the range of Y sensors is going to be bigger as compared to the range of Z sensors. The input that we will give to our genetic algorithm will be a bit pattern, and that bit pattern will represent the network layout. But the layout doesn't relate to the position of nodes in a network, but in fact it relates to the type of nodes in the network. For example, if we give a bit pattern as input, in that bit pattern 1 will represent X sensors, 1 will represent Y sensors, 0 will represent Z sensors, whereas 0 will represent inactive sensors. Here are some of the parameters that we want to optimize. Field coverage will be represented by FC in the upcoming slides. Sensor per cluster in charge will be represented by SPCI. Network energy will be represented by ME, and sensor out of range error will be represented by SORE. So I will use all these symbols in the upcoming slides. For example, in the fitness function, I'll use these symbols. What we want to do, that is, out of these four optimization parameters, we will want to minimize network energy and the number of out of range sensors, whereas we will want to maximize field coverage and the number of sensors per cluster in charge. Here's our fitness function in red. The alpha values over here, alpha 1, alpha 2, alpha 3, and alpha 4. We want these are our weighting coefficients. I have already acquired some values for these coefficients from another paper. So the coefficient for field coverage, alpha 1 has a value 4, sensor out of range error, alpha 2 has a value 10, sensor per cluster in charge, alpha 3 has value 1, and network energy alpha 4 has value 1. Here's the code for my fitness function. In this code, the total number of sensors is represented by n, and I assume that my network contains 20 nodes in total, and the number of out of range sensors, I just have given it a static value of 2. The other values, which are like the inactive nodes, the number of inactive nodes is given by S. The number of X sensors is given by X1. The number of Y sensors is given by X2, and the number of Z sensors is given by X3. These are the four equations which represent our four optimization parameters, and you combine all these four equations over here in our fitness function to get our final fitness values. Here are some of the results. For example, we have the best fitness and mean fitness values, current best individual, best worst and mean scores, and selection functions. To conclude, we have used genetic algorithm for this project to find optimal node placement scenarios for wireless sensor networks. We have assumed that our nodes are in three different modes: the X nodes, Y nodes, and Z nodes. And we give the layout of all these nodes as input to the genetic algorithm, and the genetic algorithm comes up with network designs in such a way that network energy and field coverage are optimized. That's it for my presentation. Thank you for your time and consideration.